So now let's talk about how we would measure voltage, current, and resistance in our series circuit. So one thing to remember is that anytime we put a meter to a circuit, it's going to affect the operation of the circuit in some way. So we need to make sure that we're inserting our meter correctly for measuring what we're trying to measure. So voltages, when we measure voltage, we can measure all of the voltages in the circuit without breaking the connections in the circuit. Voltages are quite simple, actually. We have this is a voltage supply, kind of like a battery, that we've connected to our 3 series resistors, and then we've connected them back to the negative terminal of our battery. And we can just take our multimeter and measure on either side of the resistor to find our voltage readings there. Okay, so we're measuring a drop in 6 volts across R1. When we put the positive terminal to one side, the negative to another, we're assuming we have a greater voltage or potential on the red lead side and a lower on the black lead side. So in this case, we do see a drop in voltage from here to here in the amount of 6 volts. So, and that's because we have the red lead coming from the positive terminal of our voltage source and the black lead going back over here. So our current, our conventional current, is flowing this way. So when we measure from positive to negative here, we should see that voltage drop in that direction. Same thing here. We'll see a voltage drop from here to here in the amount of 1.8 volts. And here, notice we've reversed the leads. So if we had the red lead here and the black lead here, we'd see another 6 volts. However, since they're switched, we see that we have a negative 6 volts on our display screen. And I'll show you that in a minute in our multisim simulation. So when you use a voltmeter and you don't have an auto ranging meter, you want to select a scale. Sometimes you've got multiple scales you could use. You want to start with a scale that ensures that your reading is less than the maximum value that you're expecting. So you don't want to start lower than what you think the max will be. Start higher than that and then work your way down until you get to that level of precision that you're looking for. And I might show you that as well. So now when you measure current, that's completely different, and it uses a completely different circuit inside the meter. So when you measure the current, you need the current to go through the meter in order to read it. So when we use an ammeter, we're going to have to break the circuit and put the meter inside the circuit. And this is kind of what that looks like. So we have our circuit here with our resistors, but to measure the current, we actually have to remove R1, one end, and our source, and connect our meter between them so that that current, actually goes through the meter. And then after R1, we'll have to break the circuit there and put our meter in, and here and here. So notice a couple things. First of all, these all say 60 milliamps, okay? That's because in series, we're going to have the same current throughout the circuit, no matter where it is in the circuit. So we should measure the same amount of current. Now notice here we have a negative 60 milliamps. That's because we've reversed our leads. If we had the positive terminal here so that the current's coming in and leaving out the negative terminal, we would see a positive 60 just like we did for these 3. So since we've reversed it, we'll see a negative. So this is not a problem on a digital meter. If you have an analog meter that has the needle, that might be a problem. But in a digital meter, it's really not a big deal. You'll just see the negative. And if you switch the leads, you would see that same number, but it would be positive. Okay, so let's look at multisim and just look at how we would measure each of these using multisim. So let's use multisim and practice taking our measurements of voltage, current, and resistance. So I'm going to select a different multimeter this time. Let me see. I can't see what these are. Let's see. Okay. The Agilent multimeter that we want to choose. All right. So this is a multimeter. It looks a lot like the one we actually use in the lab. So I want to do a few things with this actual multimeter. so that you can see what we have here. So the connectors are right here, the two jacks right here, these are the high and the low right here, and these actually refer to, if you can see this, it's ohms 4 watt. So these are for certain, if you want to measure resistance, you can measure it here. Typically, we're going to be measuring using these three inputs over here, and those are this one, and this one that you see on this side of the machine. Okay, so if we're measuring volts or ohms, we're going to have a red lead plugged into here and a black lead into this common port. If we're measuring current, we need the red lead plugged in here, and the black lead will stay here in the common. The black is always in that common port, but volts, ohms, we need the red lead here, and for current, we need the red lead there. Okay, so to connect this to our circuit, first I'm going to measure voltage, because with voltage, we don't have to disturb the circuit. It can stay exactly intact the way we built it. So over here, remember, we were measuring the resistance of those resistors before. We're going to measure the voltage across each of them now. So if I click this top one, that actually is this jack right here, and I'm going to measure the voltage across R2. Notice when I click it, you see that there's a connection there on the display, or on the jack of the multimeter. So the common port is right here. I'm going to connect that to the bottom so that I'm measuring the voltage drop across my resistor. I didn't break anything in the circuit. I'm just measuring from the outside the voltage. Now we're going to power on the multimeter, and if you want to do this in Multisim, you can. It's over here. It's called the Agilent multimeter, as you see here. And notice it's coming up to VAC. That stands for volts AC. We're going to need to click on the DC volt button until it says volts DC. And now we're ready to measure volts DC. So we can simulate our circuit, and we note that we have 2.72 volts there. Okay, if we want to measure, let's say we want to measure a different voltage in the circuit. I'm going to delete that. Let's say we want to measure instead the voltage across R1. Well, I'm going to connect it the same way, just red lead over here, the black lead over here, and those are connected, and then hit simulate. And there I'm measuring 2.27 volts, just a little bit less voltage than right here. And then what voltage do you think we would measure down here? Take a guess as to what you think that might be. I stopped the simulation, and I'm now just going to connect up my Agilent multimeter down here, and then the black lead on the other side, and move that over here. Simulate, and it's at 5 volts, so it's more than twice what our 1K ohm resistor saw as a voltage drop there. We talked also about the direction. So I'm plugging these in with the red lead toward the more positive side, or toward the more positive voltage, and then the black lead where we would have less voltage. But if you did that the other way around, for instance, I put the black lead at the top of R2 and the red lead at the bottom, then what happens? We get the same amount of voltage. It still says 2.73 if you round, but it's negative. That just means that we don't, if this is red and this is black, we're not seeing a voltage drop in this direction. The voltage drop is actually in the other direction. So if your number comes out positive, you're measuring that drop in the right direction. If it's negative, you just need to swap the leads around, and that's all. Okay, so let's talk about measuring current. Current is different. Current is a little tricky. When we measure current, we actually have to put the meter inside the circuit. So what we're going to have to do is break the circuit. So I'm going to click one of these wires and delete it so it's not there in the circuit anymore. And I'm going to need to connect the red lead from this bottom jack where we measure current, because that's a different circuit from our that's a different circuit from, I'm having trouble with my circuit here, that's a different circuit from the voltmeter. I'm still going to have the black lead in the common port, but notice now what's going to happen is our voltage source is going to supply current to our circuit, but it's going to go through the meter and then back to the circuit so that the meter can then measure it. The other thing is I'm going to have to measure current down here. It's still set to volts DC. I have to switch that to current. So DCI is right above the DCV button, and this is the same way that the meters work inside the lab. So if I shift, I'll get this up here, the DCI. And note, I say now I have amps DC, ADC. That's what you're looking for, amps DC, when you're measuring current. Now we're ready to measure. If I hit the simulate button, now we see that we have 2.27 milliamps DC, okay? And that's how we would measure current here. Okay, let's measure current. I'm gonna take the meter back out of my circuit, connect this back up, and I'm gonna measure current down here instead. Now we know that we should have the same current, right? Because R2 and R3 are in series with R1, we should have the same current throughout the circuit. So I'm going to simulate again and see that yes, indeed, we have the same current between R2 and R3 that we had between R1 and R2. Exactly the same. Okay? And as well, if I reversed the lead so that the red lead was I'm sorry, the red lead, I had it right. Okay. Escape. Okay. So let's say I put the red lead closest to ground, or the negative terminal of the source, and I put the black lead closest to the positive terminal. So here, this is closest to the positive terminal, and this is closest to the negative terminal. So if I do that, then I'm looking at the opposite of conventional current, and I'm looking at electron flow current. And notice I get that negative sign. That tells me that that's opposite direction of my conventional current, which is what I'm assuming. All right, so one more reminder before we move on, how to measure resistance, because we did that earlier, but let's talk about it again now. Resistance, we would set the meter up the same way we did voltage as far as where we plug in the leads. So you'd have your red lead plugged up here in the first spot and your black lead in the common port here, and we would measure, if you're wanting to measure RT, basically we're measuring from the positive lead of the voltage source to the negative side of the voltage source, but we have to remove the voltage source from the circuit. Remember that. Very important. We cannot measure resistance with that voltage source in the circuit and expect to get the right reading. So then you need to switch to your ohms button here. Now if you shift and hit the ohms button, you get the 4 watt ohm. That's these posts right here. If you're not plugged into there, don't do the shift first. Just hit the 2 watt ohm button and you're ready to go. So when we hit simulate, now we're measuring that we have 2.2 plus 1.2 is 3.4 plus 1 is 4.4 kilo ohms, and that's what we have there. So just try to make some notes and review how you're going to measure these things. You'll get a lot of practice in Multisim this semester.